Hi everyone! This is the second part of the Klipper firmware series. Today I'll explain how to install the firmware host on different devices. In the first part I talked about what Klipper is and how it is different from other firmware. I understand that the first part felt a bit like a lecture and maybe a little boring. This one will be a bit more dynamic. Let's get straight to the point. There are two main ways to install host part of Klipper. One way is to install an operating system that already includes the minimum set of components needed for Klipper. This method is the simplest and fastest, but it only works for devices that are often used with the Klipper and already have ready-made system images. The second way is to install a clean Linux system and set up everything manually. Manually isn't really the right word because there are helpful tools that do almost everything automatically. This method works on almost any device, but it takes a bit more knowledge and steps. The most common method is installation on an original Raspberry Pi. And even though it's the easiest, I'll explain it in full detail, because these steps and tips will help us later for more complex setups and general use. For this example, I'll use a Raspberry Pi 3B+. This one is over 6 years old, has been used with about 10 printers, and it still works. Before starting, we need to answer two questions. How will we power the Raspberry Pi and what storage device will we use for the system image? About power, for stable operation, the Raspberry Pi needs 5 volts and at least 3 amps. You can power it through micro USB or USB Type-C depending on the version. You can also use the GPIO pins with the step-down converter or a 5-volt power supply. But keep in mind that USB power has built-in protection against overload and reverse polarity. Powering through GPIO bypasses all of that, so unstable voltage could damage the board. That's why I only recommend GPIO as a last resort. For USB power, a good USB charger will work. Not a fast charger, but one that provides a steady 5 volts with a high current. From my own experience, a solid charger with the real 2 amps is barely enough, but it works. I use a 2.3 amp charger from an old iPad with no issues. Even if you see warnings about low power, that doesn't always mean the board will be unstable. But it's better to get a 3 amp power supply to have some headroom. You can also use a step-down converter connected with the USB cable. This is probably one of the best options. Both devices can share one power supply, turn on at the same time, and still have protection from voltage drops. Now let's talk about storage. The entire operating system on a Raspberry Pi runs from a microSD card. There are ways to connect a SSD on some newer boards, but I haven't tried that. Some versions and some alternatives have built-in eMMC memory. For example, I have that on the Bigtreetech CB2 board. But in the classic setup, all of Linux runs from a microSD card. That means the faster the card, the faster the system will load and work with the files. And the size of the card affects how many G-code files and, for example, time-lapses you can store on it. Almost any card will work, but the faster the better. For size, I usually use 32 GB or more, but for most people 16 GB is enough. To install operating system on the SD card, you need to flash an image onto it. There are several popular programs for writing system images to flash drives. Personally, I often use Balena Etcher. It's pretty convenient and can also clone flash drives. But for original Raspberry Pi boards, the best choice is definitely the official Raspberry Pi imager. There are also more advanced tools like Rufus, but more settings usually just mean more chances to make a mistake. You can download Raspberry Pi imager from the official website. First, select your board from the list. In my case, I choose Pi3, which also works for all third-generation full-site Pi boards and compute modules. Next, choose the OS. There are a lot of ready-to-use and tested images for different purposes. If you didn't know, Raspberry Pi is a small but real computer, and it can do many different things, from media centers and game console emulators to full servers and smart home systems. But now we're interested in other specific purpose OS than 3D printing, and here you need to find Mainsail OS. Mainsail is the name of one of the web interfaces for Klipper. The OS means it's a complete system with the Klipper and everything needed for it already installed. Select the available version, then choose your storage. Click Next and you will see a message about OS customization. In theory, you can change the device name, user password, Wi-Fi settings and enable different functions right away. But when installing a pre-built image with the Klipper, sometimes the settings work and sometimes they don't. So it's better not to touch them and just set everything up later in the system itself. Click to skip customization, confirm the card format and wait. If something doesn't flash properly, use the standard sysadmin recovery set. Restart the computer, try another SD card, try a different card reader or USB cable, run the program as administrator and so on, checking one thing at a time. After a successful flash, you need to eject the SD card and plug it back in. Now there is a Linux partition on the card, and Windows doesn't see it by default, so it might show a message asking for format the card. Just cancel it. By the way, if you really want to view Linux disk in Windows, there are special programs that can open it. There is even a driver that lets you see ext4 Linux partitions directly in Windows Explorer. But now we need the second partition on the board, bootfs. It uses the FAT32 file system and it's made specifically for setting up the device from Windows. Inside there is a file called vpaSupplicant.conf.example. You need to make a copy of it, make sure file extensions are visible, and rename the file to just vpaSupplicant.conf without example at the end. Open this file in the text editor. I recommend always using Notepad++ when working with the Linux or any configuration files. It doesn't mess up the formatting when saving. In the file, enter the name of your Wi-Fi network and the password in the correct fields. Keep in mind that Linux is case-sensitive everywhere, including the network name. These settings will work for most networks, but if your Wi-Fi has a more complex setup, you can look in the Wi-Fi README file. It has configuration examples for different types of networks. If you are using a wired LAN connection with the DHCP, then you don't need to do anything with this file. It should connect automatically. Save the file, safely eject the SD card, insert it in the Raspberry Pi, plug the power supply and wait. The first boot usually takes a bit longer and may take a few minutes. During this time, the settings from the file we created are copied into the system, and the file gets deleted. If you need to change the settings later, you'll have to create the file again or set everything up directly in the system. Now we need to find out the IP address of the device. There are several ways to do it. If you have access to your router, you can usually see the DHCP clients or the list of Wi-Fi clients. The Raspberry Pi will show up as Mainsail OS by default. If you don't have access to the router, you can use a network scanner program like Advanced IP Scanner. Once you have the address, enter it in your browser. You should see the Mainsail interface. At this point, the host part of the Klipper firmware is already installed and running. But it's a good idea to do a couple more important things. First, update everything. Ready-made system images usually don't include the latest package versions. The easiest way is to go to the Machine tab, and on the right side you'll see the Update Manager. Always start by updating the system packages, which are at the bottom. Klipper-related packages has a lot of dependencies, and version mismatches can stop other updates from working. After updating system packages, you can try updating the rest one by one. Sometimes this method doesn't work right after the system is installed. In that case, you'll need to update everything manually through the console. To do that, we use the SSH protocol, which is enabled by default in this system image. There are many SSH programs, but I use one of the oldest, PuTTY. Enter the IP address, leave the port as is, connect and agree if any prompts appear. Now we are in the console. You need to log in as user PI. The default password is Raspberry. If you want to change the password, use the command passvd and follow the instructions to set your own. To update packages manually, first update the package list with the command sudo apt update. The command sudo runs things as administrator, so first time you'll be asked to enter the password. After the list is updated, upgrade all packages with the command sudo apt full upgrade. Agree to any prompts and wait for the update to finish. Now we need to install one very useful package. It helps manage Klipper components. I don't know the correct way to say the name, but I call it KIAUH. On the official GitHub page, you'll find all the commands you need to install it. Just copy them one by one and paste them into the console. In PATI, pasting works by clicking the right mouse button. The first command installs the git package, which lets you clone projects from servers like GitHub. The second command downloads the needed files, and the last one launches KIAUH. Type 1 to enter the new version. Right away you'll see what's already installed. Klipper is the main control part of the firmware. Moonraker is an API server that connects Klipper to the web interface. In our case, Mainsail is installed as the interface, but if you want, you can install Fluid instead. Klipper Screen is for working with the touchscreen displays, and Crow Nest is the package for webcam support. KIAUH allows full control over these packages. You can install and remove them, add some extensions, make backups, and update everything. So if updates didn't work through the web interface, you can try doing it here. Sometimes in ready-made images, people include a fork of Klipper instead of original version, and it can't be updated from the official repository. Or the versions of the packages are too different and can't update properly. In that case, you can try deleting all Klipper packages and installing fresh ones manually. We'll go over how to do that a bit later. The second example today is a Raspberry Pi compute module alternative, Bigtreetech CB1. In my case, it's already installed on the PI4 adapter, which basically makes it similar to a full-size Raspberry Pi with all ports and connectors. Installing the system on this board will be almost the same as on most other PI alternatives. You won't be able to select this board or its system images in Raspberry Pi Imager, but the program can still flash any image to an SD card. You just need to find the image first. With the CB1 it's pretty simple. Go to CB1 page on the official Bigtreetech GitHub. There, under the release section, you'll find the needed images and the changelog. Since the board was made for 3D printer use, there are two types of images. One is the version with the Klipper already installed, similar to Mainsail OS. This one will work for most users. The second is the minimal version, which has to be set up from scratch. I only recommend it for people who know how to work with the Linux. The same situation with the CB2, the newer version of this module. On Bigtreetech's official GitHub you can already find everything you need. For the other boards you also need to look for the system images. For example, for the MakerBase PI board, the official image with pre-installed Klipper is stored on their Google Drive. With the boards that weren't made specifically for 3D printers, things are a bit more complicated. For example, Orange PI. For some of the most popular boards, there are Klipper images available on the Mainsail Crew GitHub page. But not all of them. If there is no ready image, you can try finding one from other users, or use a standard Linux image like Ubuntu or Debian that can be set up manually. I'll show this kind of setup later in this video. Other PI alternatives are rarely used, but they usually follow one of the last two options, using someone else's image or installing everything by hand. Now let's go back to the CB1. Download the full image, open Raspberry Pi Imager. Under Device, choose No Filtering. For the operating system, choose Use Custom and select the image. Skip customization again, flash the image, then unplug and plug the card back in. You'll see a FAT32 partition. It's called just boot here. On it there are a file called systemcfg. It works the same like on Raspberry Pi, but here you don't need to create a new file, and this one won't be deleted after reboot. You just need to do the same thing. Uncomment the lines in the Wi-Fi block, enter your network name and password and save the file. Turn on the CB1 with the SD card installed. Find the IP address and so on. The only real difference from here is the default username and password when connecting via SSH. For Bigtreetech boards, the login is BigU, password BigU. For MakerBase PI, MKS and MakerBase. For Orange PI, Orange PI and Orange PI, and so on. This information is usually on the official page, or you can just Google for it. Other than that, the rest of the setup is exactly the same as the first method. I won't repeat everything for CB2, but just to mention it briefly, I have the CB2 installed on the Manta M5P board. This board already have a slot for the compute module, so no extra boards is needed. The process is the same. You insert the SD card with the system into the right slot and power it on. But the CB2 also has internal eMMC memory, and you can move the whole system there from the SD card. To do this, use the command sudo nand sata install and choose the option boot from eMMC system on eMMC. Agree to everything, wait for it to finish, remove the SD card and the system will boot from internal memory. I haven't tested how this works on other boards with the eMMC. Most likely there are two options, either a special tool or a command to move the system. The last way to install a full Klipper setup that I'll show you today works on almost any laptop, nettop, mini PC or desktop that can run Linux. The only thing you really want to have is ability to connect display, keyboard and mouse to that computer. It's possible to install Linux blindly, but that method is harder and requires Linux admin's experience. So I'll be showing the graphical installation. Even though the names ARM-Bian and Rasp-Bian makes it sound like they should be almost the same as Debian, and they really are direct fork of it, they still have a lot of small differences. But surprisingly, Ubuntu, which is also a fork of Debian, turned out to be much more similar to Raspbian and Armbian than you might expect. However, Ubuntu has one drawback. In standard version it needs a lot of resources. Its heavy GNOME interface can work slow on older or weaker PCs. If the computer you're going to use is powerful enough, you can just install the full version of Ubuntu. If you don't care about having a nice interface and want better performance, there are versions called Xubuntu. It uses a lightweight XFC interface instead of heavy GNOME. Or if you are using a computer that won't have its own display later, you can install the server version of Ubuntu. It has no interface, only the console. It's more suitable for people who already understand how Linux works. I have a mid-range laptop for this example, so I'll show the installation using Xubuntu. It's done almost the same way as I already explained earlier. Download the image from the official website, write it to a USB stick using Raspberry Pi Imager. Yes, this program can write any Linux image, not just ones for single-board computers. Then boot the computer from the USB stick. Most likely this will happen automatically when the USB drive is plugged in at startup. If it doesn't, you'll need to press a special key during startup. I can't give you one exact answer because different motherboards and laptops use different keys for the boot menu. It might be F12, F9, F8, Escape or something else. Usually the classic admin method works. Or search online for the right key for your device. Boot from the USB drive and choose Try and install Xubuntu. The system will load. This is what's called a live system. That means it's a full Linux running from the flash drive. You can even install some programs on it, but any changes will be lost after restarting. In theory, you can make a live USB with data saving, but that's more for testing. For regular use, it's better to install the system properly on the computer's hard drive. To do this, click the Install Xubuntu icon. The installer will start. If you thought that installing Linux is something only geeks and computer experts can do, no, it's not like that anymore. It's even easier than installing Windows. since it doesn't ask annoying extra questions and show ads. Choose the language, connect to your Wi-Fi network. For installation type, we only need interactive installation. As for the starter application set, it's simple. If your computer is slow and will only be used for the printer, choose minimal. It only includes the packages needed to run the system. The desktop version includes extra software for media, office tools, and so on. If your system can handle it, why not? Next are the extra codecs and drivers. They won't hurt, so go ahead and include them. Then choose where to install the system. You can install Xubuntu alongside another system with the boot menu, or you can erase everything and install Linux as the only OS. Now the next important step, creating a user account. The name doesn't really matter. The computer name is how it will appear on your local network. You can also choose any username and password you like, but remember that Linux is case sensitive, even in usernames. I usually uncheck require my password to log in, but if you care about security, leave it on, it's not a big deal. Select the time zone and start the installation. Wait, restart, and now you're in the system. Open the terminal and update the system using the same commands as on Raspberry Pi: apt update and apt full upgrade. And to enable SSH access, install the OpenSSH server with sudo apt install OpenSSH server. From this point you can connect to the computer using PuTTY, just like you would with the Raspberry Pi. Now we just install KIAUH, which you already know how to do. Launch it, choose Install and go through the steps. First, install Klipper. The first thing it asks is how many instances you want to run. That's what I talked about in the first part. One Klipper host can control several printers at the same time, each connected to its own instance. We won't cover it today, but if it's interesting, I will explain it in one of the next videos. When it asks create example printer CFG, sure, why not? After the installation, you'll be asked if you want to add your user to the TTY and dial-out groups. This gives full access to USB and serial ports. You should definitely do this. Then install Moonraker, the API server that connects Klipper to the web interface, and then the web interface itself. I prefer Mainsail, but if you like Fluid more, install that instead, or even both. When it asks the first question, answer yes like before, then it will ask you to choose the port for the web interface. The default port is 80, which is HTTP port. That means to open Mainsail in the browser, you only need to enter the IP address. But if you install Fluid 2, you'll need to pick another port for it and connect using IP address plus a colon and the port number. I use default. The next options can be skipped. They were already installed with the earlier packages. Klipper screen will skip for now. If you install it, it will open, but you won't be able to minimize or close it. To work properly, it still needs some setup. So for now, we'll leave it. Crow Nest for webcam support, it's useful to install. That's it. You can open the browser, enter the device's IP address, and you'll see a Mainsail. The Klipper host is now installed and ready. And now the last bonus example. This is about installing Klipper on an Android device. A GitHub user named Utkabobor, who seems like a very smart guy, basically packed Klipper into an APK file, a standard Android app installer. You don't even need to root your phone to install it. Just download the latest release, transfer it to your Android device any way you like, or just download it directly from the browser on your smartphone. In your settings, allow installation from unknown sources, then install the app. When you open it, give it all the permissions it asks for, create a profile, enter a printer name, choose one of the example configurations, turn on auto start for the profile and launch it. That's it. Klipper host will just start running. Like in previous examples, it runs without being connected to the printer yet, but it's already working. For automatic startup of Klipper when the phone boots, you need to set Beam Klipper at the default launcher. I tested it on several phones and it started up just fine on all of them. As for Android TV, I only have Xiaomi Mi Box. To launch Beam Klipper on it, I had to install a file manager to install the APK and connect a mouse to control everything normally. Will it work on any Android TV box? I can't say for sure, but it should. All of this would be great, if not for a few problems. With the smartphone, the biggest issue is power. Most phones have only one USB port. That port must support OTG mode to connect to external devices. That's how the phone connects to the printer over USB. And even if you find a good USB hub that can charge the device, not all smartphones can handle OTG and charging at the same time. Manufacturers rarely mention this in their specs, so you usually have to test it yourself. If charging doesn't work, you'd need to open the smartphone and solder wires directly to the battery. I think it's clear that this method isn't for everyone. With the TV boxes, there is no power issue, but Android TV itself brings other problems. On many boxes, Android TV has more limits than regular Android. For example, on my Mi box with the stock firmware, I can't set Klipper as the default launcher. Also, when it starts, Klipper asks for permission to access the USB device. That means every time the box reboots, it has to be connected to the screen so you can press the buttons. I tried different apps for auto-launch and auto-confirming system requests, but unfortunately the original firmware doesn't let them work properly. Yes, you could root the device, install the custom ROM and get full access to all permissions and auto-start. But then it becomes a whole different kind of project with many different methods depending on the device and manufacturer. And not all smartphones allow this without the risk of breaking them. And really, if you are going that far, you might as well install the real Linux system instead of Android and run Klipper normally. Besides all this, without root you cannot use SSH, which means you can't install extra packages, and Klipper cannot compile MCU part of firmware for the printer board by itself. But that's a big topic, and we'll talk about it in the next video. I'll explain how to build the MCU part of the Klipper firmware, flash it to the printer board, and connect the host to the MCU. That's all for now. As always, thanks to everyone who watched this video to the end. If you want and able to support the channel financially, you'll find all the links in the channel description. Also, under the video I'm leaving links to some of the hardware I mentioned. If you use them, it helps support me and my channel. I hope this video was useful for you. That's all for today. See you soon!